Okay, in this tutorial we are going to model this M10 Bolt. Okay, so let's get to it. The first thing you will need to do is select your working directory. Make sure that you have set your working directory to your Creo folder and ideally made a folder for M10 Bolt. You don't need to type in, just press OK. Then we're going to go to New and we're going to call this M10 underscore Bolt and choose OK, and your modeling environment will open up. Okay, we're going to start with the top plane. You can select it in the model tree or you can select it in the environment, and we're going to choose Sketch. Once you choose Sketch, it should turn parallel to the screen, and we are going to then go up to the palette window. We're using the palette window because we're going to import a shape. We are looking for the 6-sided hexagon. Double click and then click close to but not in the center of the environment. That will drop in the 6-sided hexagon, but what we need to do is assign some dimensions. So first I'm going to do is click OK, and this has a default dimension here of that width, which we will set in a moment. But first of all, I want to put the hexagon in the middle by looking at these dimensions. So here I'm going to put 0, and that will move it over. Then I'm going to set the dimension of the hexagon. So I'm going to choose the dimension tool. I'm going to click on the bottom line, left click, the top line, left click, and then over to the side and press the scroll wheel as a button. This is giving me a distance between the top and the bottom, but there is a conflict between the original measurement, which we're not interested in. So we can delete that. That's selected. We can delete that, and then our measurement becomes active. That measurement is 17 millimeters. I'm going to press enter. Now I still need to get this into the middle of the environment. I now know that it's 17 from one side to the other, and we have a distance from the bottom line to the center of the environment. So in here, if I put in half of 17, then that should move this down. So 8.5, and our hexagon is now in the center of our environment, and it has been sized up to the correct size of an M10 bolt head. I'm then going to click OK. I'm then going to come across to Extrude and click Extrude. I'm going to set the depth of the extrusion at 8 millimeters, and I'm going to twist it or tilt it so I can see it in 3 dimensions, but I'm going to go to depth and change that to symmetric. That shows you that it extrudes both sides of the sketch we've just done. So that needs to be 8 millimeters, and then we're going to tick OK. Brilliant. Now I'm going to choose the top surface, hover over it, should go a kind of reddish color, and click on it once and it will go dark green. Go up and choose Sketch. Then we are going to go to the circle tool and choose center and point. Go to the center of the hexagon, click once, left click, draw out a circle until you touch the edge of your hexagon and you see a green reference line. Then click again and then click OK. I'm going to tilt it and press refit. Making sure that the sketch is selected in the model tree, I'm going to go to Extrude. That has come out. What I'm going to do now is change the depth direction to extrude to the other side. So I'm going to go and click that button, and it goes through and it removes material. At this point, we're going to go over to Options, And in Add Taper, we're going to select Add Taper, and we're going to make that taper minus 45 millimeters and press Enter. Now this is creating the angled edge. There's one more step here. Under Remove, we're going to change the material direction of the extrude to the other side of the sketch. So we're going to do that. And that's when you will see the taper that we've just created on the edge of the bolt. I'm going to tick OK, and I've created that detail on the top of the bolt. Now I want the same detail at the bottom here. Now this is much easier to do now. We have it once. The extrude is selected in the model tree. So I'm going to come over, I'm going to click on Mirror, and then I'm going to come down and choose the front plane, top plane. Click on top plane, and it will mirror that feature over to the other side, which is exactly what I wanted. I'm going to tick OK. I'm going to refit, and then I'm ready for my next step. Okay, so I'm going to rotate round so I can see the top surface. I'm going to click on that surface so it goes dark green, which was a left click, and then I'm going to choose Sketch. I'm going to come across to the circle tool again. I'm going to come to the middle. I'm going to left click once and drag out a circle. Left click again, and then I'm going to use the dimension tool to set the diameter of that circle. We are setting the diameter to 10 millimeters. I'm going to tick OK because I've completed the sketch. I'm going to go to Extrude. I'm going to rotate so I can see that extrusion now in 3D. And the depth of the extrusion is going to be 50 millimeters. So I'm going to double click on the number, type in 50, press Enter, refit, and choose OK. Right, now we want this to look as realistic as possible, so I'm going to put a chamfer on this edge. So I'm going to come up to chamfer in the engineering tab, choose chamfer, hover down on the edge surface. Now click that, puts a chamfer of 0.7 or 0.75. I'm going to set that at 1 millimeter, and then I'm going to tick OK. Okay, so we put a chamfered edge there. Then I'm going to come up and choose round, and I'm going to go into this edge here. Okay, click on that, and I want 1 in there as well. Because I used 1 previously for the chamfer, 1 will appear again. Make that 1, tick OK, and press refit. Okay, it's starting to look like our bolt now. Now we're going to put in the helical sweep to create the thread. So I'm going to come up to sweep. I'm going to rotate the nut so it's almost vertical. This is important because if it's more horizontal, when we choose helical sweep, it will turn horizontal. I want it to be vertical. So I'm going to click down, choose helical sweep. I'm going to come across and define where I'm going to put the internal sketch. I'm going to put it on this front plane. And then I'm going to choose sketch. Okay. I'm going to choose the reference tool, and I'm going to reference the side of the bolt. Very important. And then I'm going to set the center line. Click once and then come around and click again. I've created the center line for the helical sweep. And then I'm going to draw the line or the length of the helical sweep. I'm going to start below the bolt. It's very important you start below the bolt. I'm going to click once and then come up and click again, and then I'm going to disconnect. Okay, and now I'm going to use the dimension tool, and I'm going to set some dimensions of this line. So I'm going to set that line at 40 millimeters. And then I'm going to use the dimension tool. I'm going to click on the bottom of the line, and I'm going to click on the bottom of the bolt, and I'm going to press the scroll wheel. And then that allows me to set the distance of the line away from the bolt. I'm going to set that at 5 millimeters. By setting that at 5 millimeters means the length of the helical screw will be 35 millimeters, because the total length is 40. 5 millimeters of it is past the bolt. This should make sense in a moment when I do the next step. So I'm going to click OK. I'm going to set the pitch, that's the angle of the thread, to 1.5. Press enter. And then I'm going to come across to sketch the profile. Now when I do that, where we started our line becomes a reference point. So I'm going to scroll in there. I'm going to use the circle tool, and I'm going to click and drag out a circle, and I'm going to dimension that at 1 millimeter diameter. And then if I hit refit, you're going to see what happens here. When I press OK, that creates the helical sweep, the thread, which goes around, but it is at the moment material going around. We are now going to select remove material, and that creates that helical sweep. Okay, so I'm happy with that. I'm going to tick OK. Now we just need to sort out this part here. At the very top, the helical sweep would just fade away as it goes round. It wouldn't come to an abrupt stop. So what I'm going to do is choose that surface, and I'm going to choose sketch. And I'm going to zoom in. And what you can do here is we can project. You can look for the project line of the sweep. So I'm going to choose that, hover over, click that, and that comes into my sketch. Then I'm going to use a line chain tool to connect from the top to the bottom, and then I'm going to disconnect. I'm then going to tick OK, and then I'm going to choose extrude. And what you've got happening here is it's coming towards me. If I pull that, what I'm going to do is push it right through, out the other side, and choose remove material, and that will blend away the thread, so it comes to a sort of natural finish. So then I'm going to tick OK, and I've completed my M10 bolt. Now in this part, in the next part, I'm going to show you how to apply a material and do the renderings. The material we are going to apply is titanium. I'm going to make this a titanium bolt. So I'm going to go up to View. In View, we can apply materials. I'm going to click down in Appearance. There we go. Click down in Appearance. And in the library, we've got standard metallic materials in the library. My model here is grey at the moment. So I'm going to choose titanium. I think it's this bottom one. If I hover over, there we go. PTC standard titanium. So I'm going to double click on that. That appears in my appearance library. I'm going to click on the M10 bolt, and that selects the entire bolt. Okay, I'm going to double click on the material, press OK, and I now have titanium applied to my model. Right, I'm then going to set the scene. The scene, now there are lots of different default scenes, but I really do encourage you just to use the standard default scene here. But go in and edit it Let me go into the renderer now and you'll see that scene appear. So let's go to Render Studio under Applications. I'm now going to go into Render Studio. Okay, so now you can see it's sitting on a surface. This is the scene. Now I'm going to go to Scene and I'm going to edit that scene because it's got quite a grey background. I want the background to be white, so I'm going to go to Colour, and the default colour is white. And I like this because then you're focusing just on the product. I'm going to close that. You can set the perspective, and then you can set the position or ready for the render. Okay, now in the renderer there are lots of options. You can either use the real-time settings that are pretty good, as you can see on screen, or you can deselect that and then you can select anything from basic right up to custom, and you can do your own settings. I'm going to change this to product and you'll see a change in the environment. It changes to the amount of light that's hitting the object, the amount of light that's bouncing off the surface. Okay, and I didn't mean to do that. And then I'm going to browse, and that goes to my folder, and I'm going to call this test, and that will send a test render to my folder, and that will be a product test render. And now obviously I can change all these settings higher, so it will take longer, and I'll get a higher and better quality image. I'm now going to go to that folder, so I'll just bring that up here for you to see, and that is a sort of basic rendering. I can play around with the settings to get a much higher quality. The renderer in Creo is very good. Okay, experiment with that, and then you can do an assembly to add your M10 Nut to your M10 Bolt. I will show that as a separate tutorial after this one. Okay, what I'm going to do now is I'm going to show you how to assemble the M10 Nut and the M10 Bolt. So I'm in the M10 Bolt. I'm going to create a new file. I'm going to go New, and this time I'm going to choose Assembly, and I'm going to call it, I'll do nut_bolt. Okay, that creates the assembly environment. I'm now going to click Assemble, and I'm going to bring in my bolt. You can move that around anywhere. And what we need to do is lock this to the planes, the different planes that are in the assembly. So if you click on the plane from the bolt, it creates this chain, and then connect that to the plane in the assembly, and you can see the bolt move down. Then you can choose the front plane, or right plane, sorry, and then connect that to the right plane. We can change, that has a distance, we can change that distance to 0, and then that will match that. And then we just need to connect that one to this one, and then it's gone orange, which means it's fully constrained. So when it's fully constrained, that's when you can tick OK. Right, the bolt is in. Now I've got to go and bring in the nut. Now that's in a different folder. So I've got to go into my Creo folder, and I go to the M10 Nut, and I'm going to bring in the M10 Nut. Okay, there's the M10 Nut, and I want to assign it to this. So the way we do this is we choose a common surface. So this has a cylinder, and this also has an internal cylinder. So I'm going to choose the internal cylinder, and then I'm going to select that to the external here. Okay, and that should, so let's go to that surface, and then you can see that's brought that across. And now you can see the direction handles cannot be changed, and I can only change its height now because it's locked into the cylinder. Now here for the height, what I suggest you do is choose the top surface of the bolt and the top surface of the nut, and they are locked in. Then you can define that, change it from coincidence to distance, and then you can set that at any distance as I go down. So if I do, let's move it down 10 millimeters. Oh, sorry, that needs to be a minus 10. Minus 10. It will go down the bolt, and you can set it at any distance you want. Tick OK, and then we have the nut on the bolt. Okay, so we'll do a quick assembly, and then you can take that into the renderer and create renderings of that. Okay, go ahead and do that and put those renderings into your portfolio and take a range of different renderings and maybe try the nut at different positions on the bolt with the assembly.